Okay, and we are back. So, hopefully you can all hear me now. So I have two audio input sources in my mixer and my streaming software, and depending on the day, one of them will work and the other one will not. So hopefully this is the good microphone, because I've got a good one in my headset and I've got a crappy one on my laptop. So hopefully this one works out okay. So yeah, that was an awesome presentation. Thank you very much. It was extremely interesting, I thought. And I am one of those weirdos who really enjoys procedurally generated games, um, as evidenced by my often discussions of Binding of Isaac or Dungeon Crawl. Minecraft is one that I haven't necessarily, I don't know, something about it, I just can't get into it. I don't know why. But I had a question for you about the GA aspect. So I do a lot of research work using genetic algorithms, so that kind of piqued my interest. But I'm curious, maybe can you talk a little bit about what you've seen with how games actually use GAs? Because those are pretty memory and time intensive to run. I'm actually kind of curious, and if you don't know, that's fine. I mean, it was, I think, one bullet point in a 45-minute presentation, but do you know anything about the GA aspect? Okay, so no, that's fine. I mean, a no answer is also quite valid. Um, the only reason I ask is, like I said, I do a lot of stuff with genetic algorithms. I think they're really cool, but they're also like you have to simulate whatever you are running every single value. Like, so you would do a number of generations that you want to evolve towards some answer, basically, and then you would generate a whole bunch of random candidates. And then every single generation, which is a for loop, you would evaluate every single member, which is another for loop. So basically, you have a huge amount of processing time that's required. So running them online in a game, I think, would be kind of interesting. I guess it would be a lot of like pre-generation where something like this would run. Um, but yeah, it's really cool. That L tree, I really liked how that worked too, because that's quite interesting. There's actually, since that's grammar based, there is a branch of evolutionary computation called well, it's part of the genetic programming, but it's crap, what's that called now? It's like a very specific branch of evolutionary computation where they use grammars to evolve like full programs. So you could probably make an L tree even more intelligent with a like a guided search algorithm. That's actually really cool. Yeah, and I saw that butcher scene pop up out of Diablo, and I got giddy. Um, can't remember if it was this class or my other one I mentioned, but I've gotten back into Grim Dawn recently, and that's kind of scratching my Diablo itch. Mm, hmm, okay. So other than that, um, just play Path of Exile. Diablo 3 definitely didn't scratch the Diablo itch, I can tell you that much. I'm not sure how I feel about the Diablo 4 reveals that have been coming out. Path of Exile. I haven't tried it. I've heard a lot of people like it, but Yeah, maybe I'll have to give that one a shot. Or just go back to Diablo 2. Be the old man playing Diablo 2 forever. Nothing wrong with that, really. It's a good game. Um, so let's get rid of my taskbar issues here. Diablo Immortal. Oh yeah, everybody's got a phone, right? Okie dokie. So yeah, good job. So then on Tuesday next week, we're gonna have two presentations. So I anticipate that'll take the whole class. Um, if the two of you who are set to go, if it doesn't take the whole class, well, basically we'll just leave the remaining time as like term project work time on Tuesday. So what I'm gonna try to get through today then in the remaining 45 minutes is I'd like to finish up our little ball roller that we started out last time with. So if you recall, what we had was a little ball roller, and I've kind of been mucking around with the camera a little bit. But basically what I've done so far is we added some walls, we have a plane, added a free asset texture onto the ball. If we wanted to be smart and fun about this, we could make the collectibles procedurally generated, maybe make the environment procedurally generated to tie in with Kyle's presentation. And actually, that's kind of what I've got a demo at the end here. I did a very lightweight procedural generation algorithm, and I threw a ball into that area. So, um, actually, what I'm going to do is let me pop that open as well, just so that we don't wait for an hour later on for this thing to load. You can just kind of load it in the background. So where we're at is we are going to add some collectibles. So this is prefabs in Unity. So if you want to kind of liken that to Kyle's presentation with his procedural generation, you can make prefabs for your walls. You can make them for various assets that you want to procedurally generate. So you would like make one or a small handful of them, and then your procedural generation algorithm could basically place walls in various locations. It could apply random textures based on where the algorithm is. Um, there's lots of ways you could go with procedurally generating environments, but I'm not, to kind of bounce back and forth between his points. Um, it is definitely not for everybody. That was actually a really good point. Have any of you played a game called Subnautica at all? So that was the underwater kind of not Minecraft. It was like a resource management game in a way, but my understanding was that was not procedurally generated, that it was everything was hand placed by the creators. Somebody correct me if I'm wrong on that one, but you get a very procedurally generated feel, because it is that resource management type of thing where you have to survive and craft and all that. But you can definitely tell the difference between something like that and something like Minecraft, where everything feels very organic, whereas some of these procedurally generated voxel games, um, you kind of get lost in the environment. But you know, like Cal was talking about with some of the different algorithms for smoothing out areas, it can feel organic, or if you look at some of the free to play stuff that's out there, it feels very poorly thought out, for lack of a better word. So it is kind of interesting what we can get with these algorithms. Saves the designer a lot of time. Oh, actually, that was going to be one point that I was going to mention too, not to skip back and forth here, but I'm curious if with testing these games, this is going to be a problem too, right? So if you have a procedurally generated game, any idea how we would test them? I'm gonna go ahead and start placing some cubes in here while we talk about that. So that's kind of one of the issues with procedural is you don't know what you're gonna have, right? I'm gonna place a cube in here, reset it to origin. Let's focus on it. So yeah, that was a question to you all in chat. How would you test a procedurally generated game? Move you up by 0.5. scale by 0.5, and rotate by 45. Also going to disable the player. Any thoughts on testing? Run a lot of iterations, not sure really. LOL, trial and error, absolutely. So it is very tricky to test procedurally generated games. Um, I don't know if Kyle, you ran across anything in your travels through procedural research, but a lot of the things that you can do to test are you can automate a lot of scripts, but if you notice a lot of these procedurally generated games will have a seed, so you can apply a particular seed and then the random generator will randomly generate items the same every time. Right, so you still have a nice random distribution of your, map generation algorithm or item placement or anything like that, but you're going to be guaranteed the same environment every time. So you could run through and you could do all your various tests with that. But then, once you release it to the real randomness, you're still going to possibly have edge cases that you've never considered. So testing is going to be very tricky. There's no right answer, basically, here, was kind of the takeaway. So to kind of get back with what I've been doing here, basically I added a cube, I've created a script, and I apparently started clicking and forgot to rename it. So this is going to be let's call it our collectible script. So I placed a cube, I rotated, scaled, and reset it to origin, or I reset it to origin, then rotated, scaled it. And then what I did too is I actually disabled the player temporarily. So what that means is that there's this little checkbox. You can enable or disable the player, and I've disabled it just so that I don't see it. Now, the object basically, you can't really interact with it. Startup is not going to run on our player object right now. So what we need to do now is we're going to make our collectible objects work here. First things first, I renamed this collectible, so I'm going to have to call it collectible. VS Code's taking a year and a half to load up now. All right, so we have our script, and now what I need is my notes so that I can actually see what code I need to write without flipping back and forth and being super distracting for everybody. All right, so we have our script. We have a cube. What we're going to do is make this thing rotate. So just to do a little bit of animation, basically. So every update frame, not necessarily needed to do this in like later fixed update or anything like that. We're going to call transform.rotate. We're going to give it a vector. So basically, what is our rotation vector? We're going to multiply it by delta time. So we're going to rotate it by this vector every frame. And this multiplier here is going to smooth things out. So what we should see after saving is if I run this, ideally I don't have a compiler error, which is good. Should see my cube rotating, but it's not rotating because I, like a very silly person, forgot to attach my script. That's not where the script goes. It goes onto cube. Thank you. All right, so cube has, well, 2 scripts now apparently. Let's leave it 1, and now let's get some rotation. There we go. Beautiful rotating cube. All right, so next up then, we're going to turn this thing into a prefab. So what a prefab is basically like an item template or an asset template. So if I have one object that's been defined, I've got a rotating cube. We're going to add some physics attributes to it as well. But I can take this and I can instantiate it a number of times. So think of it like creating a base asset, and then I want to expand on it and just duplicate it in innumerable amounts of times. This is going to make life a lot easier for development later on. So to make something a prefab, it's actually really easy. I created a prefabs folder here. All I have to do is drag this cube into the prefabs folder, and then you see it become a actual prefab object. So here we have our base asset, and then here in our hierarchy, we have a cube. So zoomed all the way in, we have our prefab. And I need to go to the correct window there. So if I make a change to the base asset, every single instance of this prefab will also change. So for instance, if I make 30 collectibles and I want to change the texture, changing the texture on the prefab will change the texture for all of them. So again, it's a template. So what I want to do then is to select my cube. I want to not rename it. Thank you. I want to duplicate it. And now I have another cube. So let's maybe do a view kind of like this. So I've got my original cube. Let's shift it this way. I now have another cube. I can grab this little square, which is actually the XZ plane, and kind of move it around my play space. So duplicate is, what is it again? Control D. So I can move all of my cubes. I do want the top-down view, otherwise it's not going to be as nice for duplicating. Let's move you over here. I'm just hitting Control D and dropping a bunch of cubes around my scene. All right, so 6 is good enough. I'll just move this guy up there so they're all ordered. So when I play, got 6 rotating cubes. And I could add some randomness to the update algorithm. I could add, whatever I wanted to make them behave a little bit differently in that script, but we're just going to leave it as is for now. So we have our 6 objects. Now we can also change the color of the cubes too, or change the texture. Again, we're going to go ahead and add an asset. So here I'm just going to create a basic material. I'm not going to, waste time and go download something. Let's make these a little bit different than the scenes. So you can go bright green. Sure, sounds good. And I can apply this to my prefab. So what we can do, prefab, cube. No, they did it in the wrong spot. Sometimes it's just easier to do it this way. I'm going to move my material over later. Let's apply this to my cube. Apply to cube, please. Oops. Clicking the wrong thing. Cube. Did I do the wrong... I think I clicked the wrong object. And now it's frozen. Select our prefab. So we're over here. I think I created these wrong. Let's go ahead and do this again. So I want this guy gone. And drag a cube out here. Reset it to origin. Point 5, 45, 45, 45, 0.5, 0.5, 0.5. Okay. So this should be our cube. I'm going to duplicate you. There we go. That's better. Or 5. We'll do 6. Slight hiccup there, but we should be good now. All right, so we have our cubes. They're prefabs, and now we're going to enable pickups. So one of the things that we're going to want to do here is that we want to basically trigger a collision to happen with these objects. So when we collide with something, when the colliders that are applied to our objects get triggered, again, we have multiple functions which we can use. The one that we want here is we want the onTriggerEnter function. So basically, as soon as our player collider, which is a sphere, hits the cube collider, which is on the pickups, we want this function to trigger. So the player collider will be kind of the parent collider that we're going to use, and then it's going to pass in whatever objects that we hit here. So basically what we want to do is we want to deactivate the object. So we don't necessarily want to destroy it. So what we want to add in here then is let's pick our player. Player, we want to re-enable them. And let's go over here so we get the sun out of the way. Let's open up our script. And you can already see my environment starting to get a little bit messy in terms of organization. Okay, so here we are back in our player. We want to add in on trigger enter. And then we need to pass in our collider. So other is what we're going to reference as we go. And so for now, we're going to leave this as is. Before we start adding some more code, one of the things we want to do is make sure that we are colliding with the correct object. So this is going to trigger whenever I hit anything. Right? We don't want this to trigger when we bounce into a wall, for instance, or with the floor. Excuse me. So one of the interesting things about Unity is that you can apply tags to objects. So for instance, all of my pickups will have a pickup tag. The example here, let's say that we're making a Mario game and I want to collide with a coin. Well, I would spawn a bunch of coins and I would tag them with coin. And then once this fires, I would run the pickup script that I would write, and then I would maybe bleep the little, the Mario coin noise, for instance. So what we're looking at here then is in our onTriggerEnter function, we want to find out if the game object that we've collided with has a particular tag. So we would add the pickup tag to our prefab, basically. And then we're going to set its active state to be false. So what we want is to modify this tag object. So in Unity, we're going to go ahead and pick our prefab. What we want is to add a pickup tag. So what I did, we're opening the prefab. Here's this little tag section. It's untagged. We actually see some pre-populated tags that are in there, but we don't have a pickup tag. So I'm going to add, just call it pickup. Well, that should mirror the slides. Pick up. So spaces are okay. It's case sensitive. So we have this tag now. Right? So now when we go back to our scene, we should see, oh, I didn't. I must have screwed something up with my prefab. But I can just tag all of these as pickup. So now all of these objects are pickups. Player is untagged, we don't care about it. Floor is untagged. All of our cubes have this tag applied to it. So what this probably means is that I might have although the color is prefab. I must have just messed something up with the instantiation there. But going back to our code now, this should work regardless. So we're going to deactivate an object we collided with. So if other.gameObject.compareTag pick up. So this is basically going to return true or false. Other.gameObject.set capital false. So if you look at the onTriggerEnter function in the Unity documentation, basically what it does is it destroys the other object you collided with. So we're replacing it with deactivating, and it's going to be tag based. So assuming this compiles okay, we'll save our scene. And let's play. And we should see deactivating, or at least interacting and deactivating. No, it's not deactivating. Okay. I think we need to delete the colliders. Or not the colliders, but turn them into triggers. So one of the things that we want to do too is that we want the box colliders to become triggers. So what we're going to do here is we are going to go to the collider section, set them to be triggered. And then while we're in here, we're also going to mess around with some of the physics calculation options too. So basically, this is a performance type of thing that we're going to be doing here. So basically, to hopefully I don't butcher this explanation, but the physics calculation doesn't necessarily get updated for static colliders. So if we defined a cube and it was not rotating, it would cache this um, physics calculation of where the cube is in space. So what we want to basically be doing is that we want to tell Unity that this is a dynamic collider. So it is rotating. It's going to have to be recalculated. So what we want is to apply gravity to this. So we want this to basically have a rigid body. So it does not have a rigid body right now. So we're going to add this on. So we're going to play. Cubes disappear because gravity is applied and it's going to interact. Well, it's not going to bounce off the plane basically. So I'm going to disable gravity, but gravity might be useful still. You know, we still want the rigid body to be a part of our scene. We want to turn it into a kinematic rigid body. So click is kinematic. So then we still get all the fun of rigid body without the gravity basically. And as I roll around, we are not bouncing off cubes anymore. Effectively, the summary here is that if we're going to add a rigid body, gravity will be a problem. But if you turn it into a kinematic rigid body, then it's not going to fall through the plane. We're not going to react to like the add force function, for instance. And the other aspect here was adding the is trigger to the box collider. So basically, we need that trigger function to actually fire off. Okay. So if we are good so far, yeah, about 20 minutes left. So we have cubes to pick up. We have all of that going on. Let's go back to now scoring this and ending it basically. So a score in this game, you know, you could consider this like an arcade type game where you have a score, or you can consider it to be any other attribute that you want to add in as well. Here we're just going to keep an eye on how many cubes we've picked up, and once we hit all cubes, we're going to trigger our win condition, basically. So in our player controller, to keep track of our score, we need a private int score. Okay. So every time that we pick up an object, we'll just increment it. So in start, we'll set it equal to 0. We'll increment it in our collision detection function. Right, so we're going to go to our start, score equals 0. So we're going to initialize it there. And then if we have a collision object, we're going to increment it. So score plus plus. There we go. So basically collide with an object, update your score. But now we need to be able to display it. So what we need is a UI text element. So basically this is going to instantiate something in your scene called a canvas. Basically you're going to see a canvas and an event system pop up. These are required. They're necessary. They're going to be used for basically how text is displayed, how it looks, how it's scaled, kind of that thing. Now in here, I would do, wait for compilation, save. So I'm going to do game object, UI, text. All right, so then we get kind of this XY plane canvas here. It's really hard to see. If you zoom way out, it looks massive. But if you go to your game view, you would actually see it kind of down here. So it's actually mimicking what your 2D screen is. So let's go back to our scale there. So first things first, so we see canvas, we see text, we see event system. These are all necessary for the UI element. First thing we can do is we can make it more visible. So let's go to our text element. We see here in our inspector that we have text-related properties. So we'll call this score placeholder. Kind of see it updating up here. We can make it white by just changing its color property to make it white. And now when we play, we see it here in the bottom corner. Score placeholder. So I'm just going to give it some default text to start out with. We're going to change that pretty much immediately. I'm also going to make the font size 18 to make it a little bit bigger. This is also being treated differently than the other objects too. I mentioned that it's kind of mimicking your screen. It's a rect object, so R-E-C-T, not R-E-K-T. But what we want to do is move it to the top left here. So this little alignment box, for lack of a better word, is basically where we're going to put it. So you see some presets here. Shift, also set pivot, also set position. So we want Shift and Alt, and then I'm going to pick the upper left corner. So you see the text disappear. We go to our game mode, and then we see the text up in the top. Then we want to give it some breathing room, so we're going to update X by 10. And interesting, we're going to update Y by -10. So we have basically this XY kind of positioning here. So again, kind of more like your monitor than anything. All right, so placed it, given it some padding, and then we're going to add in. So now that we have a component here, we need the UI workspace or the namespace in Unity Engine. So let's go ahead and add that into our using section, Unity Engine.ui. So we're going to pull in these references that we're going to need. We're going to need a reference to this particular object, and then we're going to need to initialize and update the score as we go. All right, so public text count text. So we're going to basically create, again, a place to drag that text element into our inspector. And then we're going to initialize it. And I'm going to save you the rigmarole of what a function definition is, but basically we're going to create a function for setting the text, and then we're just going to initialize it to be whatever the current score is. So we're going to say void set count text dot text equals score plus count.toString. So again, variable types have to match in C#, otherwise it will yell at you. Basically, we have, oops, this is count. This is where auto-completion is going to kill me. Save, please. Thank you. So score, and then tack on the count variable. Not count, it's going to be score. Sorry, score.toString. I had the wrong name. And then what we're going to do is we're going to put this in the start function and then in the onTriggerEnter function. All right, so we're going to initialize it to score. So we want to set count text. So it's going to be called when we initialize. And then every time we update a collision, we also want to call that. So set count text. Let me know if you guys have any questions at all as we go. So now what we should see is a, oops, I screwed something up. Public, capital text. All right. So object reference not set. Oh yeah, so I forgot to drag the object on. So if you see this error, no reference exception, object cannot be set to an instance, basically it doesn't know what count text is because I have never applied this text object to the player. So if you remember, we added this public variable for the text. We need to drag our text element to reference it. So now it should be better. Score 1. Interesting. Do I have one set at the origin? I must. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Yeah, okay. I forgot to move this guy. Like, it shouldn't be starting out with a positive score. That's not right. I didn't move the cube. So, every time I hit a cube, increments the score. There we go. Now we need our win state, our win condition. So, we have our score updating. And now we need a win condition. So basically what we're going to do here is we're going to pop up a big text element that says you won, good job, kind of a thing. So basically we're going to create a new text element. We're going to add it to our player script. And then we're basically just going to see, have we hit 6 cubes? All right. So what we can do is, let's say public text win text. I could also just update the score text if I wanted as well. But what we're going to do is we're just going to say win text equals nothing on start. So we're going to initialize it to be blank. And then if we have score, or if we have hit everything, we would add a win condition. So first things first, let's add this element. So new UI text. Right, so we have a second object here. Let's call this win text. So make this 18. Let's make it white so we can see it on the blue background. And now we have another text element here. If we go into game view, we should see win text down there, which is good. We want to, let's rename this win. Let's rename this one score, just so that we know. Yeah, it's very easy to get lost in your hierarchy here. We have to apply it to our player. So I didn't create it apparently. Oh, there's a compiler error. Public text win text, and then we need win text dot text. I forgot that guy. So now we should have a non-broken build. Okay. Player object now has this win text location or attribute. Didn't mean to click that. We want to drag this in here. So there's our win text. I could also pick this little circle and then pick any of the objects in there. Save our scene. And now, so we have 6 objects, right? So if score is greater than or equal to 6, win text dot text equals you win. 1 exclamation point. You need several exclamation points, otherwise it doesn't count. All right, so we're going to be at 0, 1, 2, 3, 4, 5, 6. Then our win text should pop up. And one of the other things that we're going to do too is for win text, right now it's in the bottom. Let's put it right in the middle. And I think that's where it's going to be. Yep, right in the middle of the screen, or right in the middle of the camera view. So now when we play, win text is blank. 1, 2, 3, 4, 5. You win. Hooray. Now what we can do is we can add a little bit of pizzazz. We could add our audio data that we looked at before. So, I'm not sure if the audio is actually going to work on the stream here since, oh, maybe if we do this, we unmute it. Sorry, thinking around with audio settings still. There we go. All right, so we had this sound, right? So we had our sound. We know it works with the player. So what we're going to do is we're going to go back into our script. We have our reference to our audio somewhere. Oh, you know what? It was in a different place. Yeah, it was in our Hello World script. So what we can do is we can also add that code. Sorry, bouncing around here. Hello World. All right, so we want our audio source. So we got private. I'm just going to copy it. I could probably just have referenced this elsewhere, but we'll just add it in here. Audio data. All right. Then I think that's all we're going to need there. So in our player script now, hopefully, we should have a audio source that we can add in. Let's drag this guy. Let's drag this guy. What am I doing wrong here? Feel like I'm missing a variable. Erm. Oh, yeah. I need a audio source. Did I? There we go. Okay. So, that's right, I created it as a child. So, my bad. We need the actual object. Otherwise, we don't have an audio source. So, that's why I like screwing up in front of you guys, because it's good to see what hopefully the resolution is. So now, in our score, we can just say audio data.play 0, and hopefully this works. So again, this is just the code from the last lab, or the last section, so play the audio source. I added it as a source there. Now I've got basically duplicate audio sources.
Congratulations!
What we want to do is make sure it doesn't play on awake. We want it to play when our condition holds. And now it's not going to play. Okay. Well, I screwed something up there. That's good. What did I mess up? Oh, there's no audio source attached to the player. Yeah, there is. It's right there. So I did have an error. I'm surprised it let me play. Player. Oh, you know what? I know what I did. I know what I did wrong here. All right. Audio source. Go away. Player. We do not need this to be public. We want it to be private. And then that's going to be right. That's going to be right. We want to add it as a component in the player object. My mistake. Okay, there we go. That's what the correct way to do it is. Still don't want it to play on awake. But now our script should not have this as a variable anymore. He's got it. Yep, you guys know more than me here. All right, so audio data does not exist. Yeah, it does. It's right there. See? Audio data. Oh, audio data. Fester flails wildly on stream. Yes, there is. Play. Doot. Doot. We'll come back for you.
Congratulations!
Absolutely. Okay, so that's our win condition there. Now, the thing is that the text is very, very small. Yeah, that's one of the things with Unity that always gets me, is the adding in of objects, whether it's public or private, in terms of if it's attached to the player or not and all that fun stuff. So the text is actually set to pixel perfect by default. So we want these to basically be larger. So you see UI scale mode, constant pixel size. We want to scale with screen size. And then you can set this to be like, I don't know, 1280 by 960 or whatever your scaling mode you want is. So now the text is going to be rendered less pixel perfect and more, yeah, it's going to be larger. So I put this up on my website. We'll see how this works because I made a few tweaks to it, so this is a slightly different version. Lovely free made with Unity. So I've got my ball roller here. It's very chunky on stream. Oh, this is bad. Can't control it. Oh man. Yeah, let's not play this one. I've got it loaded over here. No, I don't have it loaded over here. Oh no. Come on, Unity Hub. Wake up. 4900 ball roller. So I'm just going to show you guys this, and then I'll show you the dungeon generator because it ties in with Kyle's presentation. So out of curiosity, while this is loading, how's everybody's projects going? Wow, this is still brutal. The only thing is, hold on, let me... Oh, I'm an idiot. We all knew that anyway. I've got the frame rate set super low. This was part of a demo that I was going to do in class about frame rate. We don't want frame rate of 3. Let's just comment this out. Go with the default settings. Apparently I built it for the web with frame rate of 3. There we go. Smooth. Oh no, the browser one's actually good because I was trying it last night. Now it's more fun. What I did here, so if you win, I'm just going to pull it over here because this is actually a different way you can look at things. If you don't necessarily want to attach a game object to your script, you can actually call this find function and it will look for something with this particular name. So like I do game object.find floor, set active false, and it deactivated the floor. And then ball falls into the ether. So then the last thing which we're going to do, so I've got this dungeon generator, and I kind of showed you guys this, I think, last time, but I found it really interesting, mainly because I really like procedural games, you know, the NetHack, Rogue, all that kind of thing. So basically what I did was I took the ball roller and I slapped a cellular automata dungeon generator into it. So basically what this does is it simulates cell growth effectively. And the reason why I picked this one is that if you are into the whole roguelike scene, they will often encourage people to develop their own. And they have a bunch of map generation algorithms out there. So they have actually a C# implementation of this map generator. So all I did, you actually see all these blocks popping up here in my my scene. I've got this map generation utility. All I did was I copy and pasted their code. I tweaked it slightly to work with Unity, but basically this will generate a 2D map where I added a render function and basically just said for every, you know, a 2D loop of the map, if it is a wall, just make a cube of my, or sorry, make a clone of my prefab and then just place it where the map says it's supposed to go. Now I've got to keep track of the X, Y, and Z coordinates every single iteration, but it actually was a fairly seamless implementation. This is an algorithm that is set to generate a two-dimensional map. And like I said, it's pretty straightforward to generate. So it's kind of fun to mess with. I've been considering adding in like a staircase system where you roll over a particular area, which should be adding a non-collidable mesh with a trigger, and then that would trigger go to the next section and regenerate the map, for instance. So my map generator. So basically, I just have a link to the web version of this. I built it for WebGL, and a link for how you can not procedure, how you can script out instantiating your prefabs at runtime. So I've got those up there as well. But other than that, yeah, so that's pretty much it for today. So definitely a strong start for presentations. I love the procedural aspect. Looking forward to who we have on Tuesday. And if you've forgotten already, graphics. On Tuesday, we have Remington and Adam set to go. So if both of you could email me how you're going to present your material, ideally before the day of, but feel free to work up to the deadline if you have to, just so that we make sure that everything is up and running and okay. So we'll do that on Tuesday. Thursday, Dalton's gonna go, and then after that, we've got Olivia, Connor, and Yasmin, and then be pretty close to the end of the semester. So thank you all. It's been fun. Have a wonderful day, wonderful weekend. Stay safe out there.